what is the probability of the arrow stopping on a consonant or one of the first four letters of the alphabet? So I'm going to show you this one. Rather than listing two events out completely separate, I'm just going to have all of the events listed once, and I'm going to use two different colors. So that's an alternative to writing this out twice. So I am going to first circle the consonants that are on the wheel. I just listed them out horizontally rather than circling them on the wheel. So consonants are the letters that are not vowels. So A, E, I, O, and U. So E is a vowel and A is a vowel, but the other letters here are called consonants. All right, so those are my consonants. And then in a different color, I'm going to circle the first four letters of the alphabet. So there's A, B, but that's not an option, C, D, but that's not an option. Okay, so by using two colors, I can see there's an overlap here because I circled the letter C in both colors. That's overlap. It means that it worked for one category and the other at the same time. So with one spin of this wheel, if I landed on C, I'm meeting both categories. That's an overlapping event. So with overlapping probability, what we do is we take the probability of the first event, which is a consonant, and we add it to the probability of the second event, which is the first four letters of the alphabet, and we subtract anything that happens at the same time. All right, so my first probability would be the stuff that I circled in red, my consonants. Blue. My consonants were J, C, F, and X. That is 4 letters out of the total of 6 letters. My second probability is the stuff that I circled in red. Of the first 4 letters of the alphabet, 2 of them are on the wheel out of 6. And then I would subtract anything that I circled twice. C meant both categories. So there was 1 letter out of the 6 that worked for both categories. So I would do 4 6 plus 2 6 minus 1 6. I can type that in my calculator a few ways. I'm not going to spend class time doing that. I showed you enough to have typed that in your calculator, all right? Ultimately, you end up here with 5 out of 6. The answer to the first one was 5 6. Which kind of makes sense, right? Look, I have 6 letters here, and I circled 5 of the 6. The only letter I didn't circle was B. So 5 of the 6 letters meet one of the 2 categories, right? The next one says, what is the probability of the arrow stopping on X on the first spin and F on the second spin? We're spinning twice. Anytime you have multiple events, this is independent probability. This is the only one of the probabilities that we learned that is for multiple events. So because I'm spinning it twice, it's got to be this one. So independent probability says take the probability of the first event and multiply it by the probability of the second event. So I'm going to take the probability that the wheel lands on X, 1 out of 6, and multiply that by the probability that the wheel lands on F, 1 out of 6. And I can type that directly into my calculator. The answer to this one is 1 out of 36. The last one says, what's the probability of the arrow stopping on J or A on one spin? It's not independent because it's only one spin. So let's think about the J's and A's. There is no overlap there. I did not circle anything twice. If there is no overlap, we call these mutually exclusive events. So I'm going to take the probability of J and add it to the probability of A. All right. The chances that that wheel lands on J is 1 out of 6, and the chances that it lands on A is 1 out of 6. I'm going to use my calculator to add those two probabilities together, and when I simplify, I get 1/3. All right, so the answer to this one was 1/3. One of each type. This is what we did yesterday and the day before in class. Today we are going to learn the last new thing of the unit, and that is called probability from two-way frequency tables and conditional probabilities, okay? What we will need for today's class is a toolkit and your workbook. So if you don't have your toolkit out, take it out, keep your workbook out as well, all right? We are gonna head to toolkit page 6. Alright, the table below shows data about student involvement in extracurricular activities at a local high school. Okay, it is showing me two different categories of things. I've got gender in one category and I've got involved and not involved in activities in the other. I'm comparing two things, alright? The first question says, how many total females are there? That question doesn't specify whether those females are involved or not involved. I don't care. I just want to know how many females are there. So I'm going to find the female category. So here's the name female. Okay, and I'm just going to go over. I don't care if they're involved. I don't care if they're not involved. I just want all of them. Okay, so there are 259 females. So this question, how many total females are there? We're going to write 259. The next one says, how many people were not involved in activities? It doesn't specify a gender. I just want to know how many people aren't involved. So I'm going to go to not involved. And this is a column, so I'm going to go down. These are the males that weren't involved. These are the females that were involved. These are the total not involved. So this one is 265. How many total people are there? What do you guys think? How many total people are there? Anybody have a guess? Not a single guess. It's the 516. Your total is always going to be this bottom right-hand corner number. It's where my total meets my total. So it's my total of the activities meeting the total of the genders in this bottom corner. This number is always going to be your big total. So 516 is the total amount of people. The next question says, how many males were involved in activities? So now I want to see where these two categories meet up. So here are my males. And here are my involved in activities. Those two categories met up at that 112, right? So the males involved, those two categories cross at 112. So the answer to this question is 112. Right now we're just working on reading the table, seeing how a two-way table works. Now 43, 44, and 45 all have the letter P there, which means probability. In order to have a probability, you need to have a fraction, okay? So my answer to these ones are going to look different than my answers to 39 through 42 because these ones are going to be fractions. So it says find the probability of male. So the first thing I want to do is I want to figure out how many males there are, and then the second thing I want to do is figure out how many people there are, because that's the total, right? So I'm going to go to males. I don't care if they're involved or not involved. I just want the males. So 257 over how many people are there? Well, Seth just told us there was 516, right? If you can simplify these fractions, you need to. So I'm going to type that into the calculator. 257 divided by 516. Math, enter, enter. It doesn't reduce, it doesn't change. So I'm just going to leave that as is. The next one says, find the probability of involved in activities. So let's look at the involved in activities. There are 112 males, there are 139 females, there are 251 total people involved in activities. Out of, in probability, the bottom number is always the total, right? And the big total in this case would be the 516. And then I would check to see if that reduces. So 251 divided by 516, math, enter, enter. It doesn't reduce, so I'm just gonna leave that one alone. Female not involved. So I wanna see where the females, there's 259 of them, meet the not involved, there's 265 of them. Where those two categories intersect is at that 120. You can see I circled that one twice. So the number I'm looking for here is there are 120 females that are not involved in activities. But because this is a probability, I need the denominator to be out of the total number of people, which is 516. So I'm gonna do 120 divided by 516, math, enter, enter. So 10 out of 43. We're gonna add one. There is some space kind of off to the side on this one, like off to the bottom corner. I want you to add in this last one. Probability of male or involved in activities. I wanna know the chances that if I randomly pick one person, that one person is either male or involved in activities. I'm only picking one person. When we're picking one thing, it's either mutually exclusive or overlap. I need to figure out what that is. So to do that, I'm going to focus in on, first, the males. All right, so the males are those people, right, those 257. Second, involved in activities. Do you think this is mutually exclusive or overlap? Did I circle anything twice? It's overlap, okay? So to do an overlapping probability, you first do the probability of the males. All right, so I'm just gonna find the probability of males. We actually already did that in number 43. The probability of male was 257 over 516. I'm going to add that to the probability of involved in activities. We actually already did that too. We did that here. Involved in activities we said was 251 out of 516. What I need to do is I need to subtract the overlap. What number do you think is the overlap? Connor? Oh, go ahead. 112. 112 is where I circled in pink and green. It's where male and involved in activities happens at the same time. It's the males who are involved in activities. I need to subtract the 112. So you're still going to have mutually exclusive and overlapping probabilities happening as practice in these tables. They just look a little different, okay? The categories are written here for you. So what I'm going to do is I'm going to add these fractions in my calculator. So 257 over 516 plus 251 over 516 minus the overlap 112 over 516. Math, enter, enter. The calculator will do the hard stuff. We just have to know what to put in. So the answer to this one is 33 over 43, I think it was. There's one more of these tables. I want to use this one as a practice for you, okay? So you are going to try the next ones on your own. I added in one, female or junior, so add that one in as well. All right, take a few moments, see what you can do with this table. And we'll go over them in, let's see, there's 1, 2, 3, let's say like 3 minutes, 9, 10. All right, guys, let's have you read the table. How many total people are on the committee? 12. The total is all of the people on the committee. There are 12 of them. Of those 12, how many are female? 6. So the probability of female would be 6 out of 12, which you need to reduce to 1 half. All right, of those 12 people, how many of them are seniors? 5. So the probability of seniors would be 5 out of 12, which doesn't reduce. So I'm just going to leave that as 5 out of 12. All right, how many are males and juniors at the same time? The male juniors. 3. That category meets at 3. So this is 3 out of 12, which you should reduce to 1/4. All right, of those 12 people, how many are female and juniors at the same time? 4. So 4 out of 12, which you should reduce to 1/3. All right. So for the last one, it's female or junior. There's 2 categories here separated by an or, which means it's mutually exclusive or overlap. I need to figure out which one. So I'm going to look at the females. I'm going to look at the juniors. Are there any female juniors at the same time? Yeah, so I could randomly pick someone who meets both categories. That makes this an overlap. So I'm going to take the probability of female. Female would be 6 out of 12. Plus the probability of the juniors. There are 7 out of 12 juniors. And if I were to just stop right there, I'd get 13 out of 12, which makes no sense. So I have to subtract something. I'm going to subtract the females who are the juniors at the same time. How many female juniors are there? 4. So the overlap is 4 out of 12. The answer to this one, 9 out of 12, which reduces to 3/4. You feel okay with that? So the first thing I wanted you to be able to do in today's class is read these two-way tables. The second thing that we're gonna do is called calculating conditional probability. How many of your parents ever said something like, you can go out with your friends this weekend under one condition? Have you heard that? I feel like every parent has said the under one condition. So probability, conditional probability sets the condition. So it's like, you can go out with your friends this weekend under one condition. You gotta clean your room. The one condition is you gotta clean your room first, and then you can do the other thing, right? So this is gonna set a condition. You gotta look at that condition first, and then you can do the other thing, all right? So conditional probability, the probability that an event will occur given that another event has already happened. In conditional probability, your denominator changes from the entire population to a specific population. In the past two tables that we just did today, the denominator was always the bottom right-hand corner number, the big number. In conditional probability, it gets more specific. It narrows down the population. It changes the denominator to something else, all right? You can write conditional probability of event B given that event A has already happened like this. It's P of B given A. That line in the middle is called the given line. So it reads the probability of B given that event A already happened. The population you're going to focus in on is the A's. And then while you're looking at the population of A's, you'll then look at the B's within that population. So the condition, which is the second thing, has to happen first. You are only going to change your denominator from this one if you see that line, okay? So in numbers 51, 52, and 53, there is no line. You see how 54, 55, 56, and 57 have that line in the middle? My denominator is going to be different. But for 51, 52, and 53, my denominator is still going to be the big population. I'm not setting any conditions here because I don't have the given line. All right? So for the first one, this is just practice with what we've been doing. It says, what's the probability of 46 to 60-year-olds? So I'm going to find that category, 46 to 60. I don't care if they are for, against, or have no opinion. I want all of the 46 to 60-year-olds. So that's 170. And because no condition is set, I'm still using the big population. So this would be 170 out of 1,000. You can always check to see if that reduces. Math, enter, enter. All right, so 17 out of 100. The second one says probability of against the bill. So I'm going to find the category of against the bill, and regardless of the age, I want the total. So 120, and there's no condition being set because there's no given line yet. So I'm still basing this off of the 1,000 people. 120 divided by 1,000, math, enter, enter. 3 out of 25. Find the probability of 18 to 29 for the bill. So I want these two things to both happen. It doesn't say 18 to 29 or the bill. It says for the bill. So I'm like just finding where those two things meet. I'm finding the overlap of those. So where 18 to 29 meets for the bill is at 310. And again, this is going to be out of that population of 1,000. So 31 over 100 then. Now, number 54 is where things change. It says, find the probability that someone is 60 given that they have no opinion on the bill. The condition. It's like, find the probability that someone is 60 under one condition. The one condition is they have to have no opinion about the bill. The important category that you're focusing in on is the given category. I want to look at the people who have no opinion on the bill. So I only want to focus in on the no opinion people. The numbers for 54 that go into your fraction can only come from the blue circled numbers. I'm not going to use the 1,000 here. I am focusing in on the population of people that have no opinion. Of those people that have no opinion, now I want to look at the 60-year-olds. So the condition is met by looking at the blue stuff. Now I can do the other thing, which is look at the 60-year-olds, right? So it's someone is 60. I'm assuming that means, oh yeah, over 60. So over 60 is 40 people in that category, and the total people in that category is 100, not 1,000. It's the total people who have no opinion. That's my denominator. You can type that in your calculator to reduce the fraction, but that's 2/5. All right, let's look at the next one. It says, find the probability that someone is no opinion given that they are over 60. Find the population that someone has no opinion under one condition. The one condition that has to be met is they have to be over 60 first. So I'm going to look at the over 60 people first. That's the conditional stuff. So here are the people that are over 60. I'm focusing in on the over 60 people. Now that that condition is met, now let's look at the other thing, which is of those people who has no opinion. 40 of them, right? So it would be 40 out of the total of that category was 210. So the denominator changes to that category of people. So 4 out of 21. The next one, number 56, says, find the probability that someone is 30 to 45 years old, given that they are in favor of the bill. So find someone that's 30 to 45 years old under one condition. The one condition is they have to be in favor of the bill first. So let me look at the people who are in favor of the bill first. These are the people that are in favor of the bill. So once I focus my attention on just those people, the condition is met. Now that the condition is met, let's look at the first category. How many of those people are 30 to 45? So I just look at that category of the circled numbers, and that's 200. But my denominator is not the entire population anymore. It's only the people that are for the bill. So I'm using the total from this category. So 200 divided by 780, math, enter, enter, 10 out of 31. It seems like the next question is similar, but it's not. It's flipping the condition. And when the condition is flipped, then I'm looking at a different category of people. So it says, find the probability that somebody is in favor of the bill under one condition. They've got to be 30 to 45 first. So now I'm focusing my attention on the 30 to 45-year-olds. And now that that condition is met, now I can look at the other thing, which is the people in that group that are in favor of the bill. Still 200. But now the population that I looked at changed. It's not over 780 anymore. It's over the 30 to 45-year-olds, which is now 240. I believe that's 5/6 if you type that in your calculator. You guys try the last two, right? They look the same, but the condition is different. I'm flipping the condition. All right, tell me what my denominator, at least my original denominator of number 58 would be. Big?
380.
I like 380. So I want people against the bill, but first they got to be 18 to 29. So the condition is I got to look at the 18 to 29 year olds. And that total is out of 380. So that denominator is the 18 to 29 year olds. Of those 380, now how many are against? That's where I'm going to pull the 50 from. And so the answer for this one would be 5 out of 38. The next one changes because now I'm looking at the against people. The condition is they've got to be against the bill first. So I'm looking at these people. Right? So now the population of people I'm looking at is the out of 120 people. So out of those 120 people that are against the bill, there are 50 in that category of 18 to 29. So 5 12. You okay with that one? Alright, last thing. I have 2 add-ins on the side that I want to talk to you about, okay? Both of these are considered mutually exclusive or overlap. And the reason that they're mutually exclusive or overlap is because of this word, right? I'm separating 2 events with or. So one of the 2 is going to happen, right? I just want to figure out if both categories can happen at the same time or not. So to figure out if they're overlapping, you have to think about, is there 30 to 45 year olds that are also for the bill at the same time? Are there 30 to 45 year olds that are in favor of the bill? Do they exist? Yeah, there's people in that category. So this is overlap. Now over here, is there anybody that's 18 to 29 and over 60 at the same time? Is that possible? No. So this one would be mutually exclusive. So just to show you what that looks like physically, I'm going to take a highlighter. So I'm going to highlight the people that are 30 to 45. All right, and then in a different color, my pen lets me, I'm going to highlight the people that are for the bill. And what you're going to see is that the orange highlighter intersects the green highlighter. And because they intersect, that's an overlap. They're overlapping at that place. So to do the overlapping probability, you're going to take the probability of the 30 to 45 year olds. That total is 240. You're going to add it to the probability of the people who are for the bill. That number is 780. And you are going to subtract where those 2 things meet, right? The green meets the orange at 200. For your denominator, there is no given line. There is no conditional probability that you need to meet. If there is no conditional probability that you need to meet, your denominator should always be the big total. The only time it will change from that bottom right-hand number is if there's a condition that has to be met first. All right, so I'm going to do 240 plus 780 minus 200. And I'm going to put that number over 1,000. Rather than typing them all as fractions, I can do it this way. You can type them all as fractions, like 240 over 1,000 plus 780 over 1,000 minus 200 over 1,000. Or you can just do it in pieces. So the answer to this one is 41 over 50. It's overlap because there are people who are in both categories at the same time. Now when I look at the next one, if I were to highlight the 18 to 29 year olds, and the over 60s, There's no overlap. Orange doesn't meet 3. So I don't have to worry about subtracting the overlap because there isn't one. So for this one, I'm just going to add the 18 to 29-year-olds to the over 60-year-olds. And because there's no given line, there's no conditional probability, then my denominators are still going to be the 1,000. The only time it changes from the 1,000 is when you see these. All right, so 380 over 1,000 plus 210 over 1,000. Math, enter, enter. 59 over 100 is the answer to this one. The only time you have to worry about mutually exclusive and overlap in these tables is when you see that word or. If you see the word or, you want to think about, is there an overlap? Can these happen at the same time? If they do, I have to subtract the intersection place, and if they don't overlap, then just add them together. All right? So that's a wrap on the unit. What I'm going to do right now is I'm going to give you a ticket out, which kind of summarizes everything we did yesterday and today, just to see where you're at. And then what this is going to do is help me figure out what we need to do tomorrow and next Wednesday, because I'm not seeing you again until next Wednesday. Okay? So, because you guys have your freshman field trip too. All right? Some of you I might see again, but I'm not doing anything on Tuesday when I'm going to be missing so many people, right? So, between tomorrow and next Wednesday, we're going to have review days for your test, which is next Thursday. So this is going to help me decide, like, what do we need to focus in on that review? Or do we not need to focus in on anything? All right, so do your best with this. If you can simplify a fraction, I need you to do that. So use your calculator to check for that. And then when you're done, you can turn this in to me. You don't have any homework tonight unless you didn't do last night's homework. And you should do last night's homework.